Okay, in the previous example, we had x being less than some value. And now we're going to work an example where x is greater than some value. Okay, so weaving errors in a roll of carpet, mean of 0.6. What's the probability of observing more than 4 errors? Again, use this to help you translate more than a number into an algebraic expression. That's where I got this greater than 4. Okay, so how we're going to do this is we're still going to use our same equation. We have our lambda, and we don't need to convert it, and we have the probability from the problem. Now, what we have to think about is these probabilities are like the x values. Well, they are the x values that we had way back in the beginning, where we had our x values, and then under that we had probabilities. Okay, so for x values greater than 4, we don't even know how far that goes out. We don't know how many trials there are. Okay, so we don't know how many times we're going to have to calculate x equals something. So for this problem, in any problem where x is greater than a number, we're actually going to calculate for 1 minus x less than or equal to that number. Okay? So what that means is we're going to calculate, we're going to do the 1 minus later, but we're going to calculate the probability for every value that's less than or equal to 4. So for 4, for 3, for 2, for 1, and for 0. Okay, so you're going to, here's where I worked it out. I'm using our equation, this equation here, for every value of x that I need to calculate. So each one of these. So for x equals 4, I've got e to the power of negative lambda times lambda to the power of x divided by x factorial. Put that in a calculator and get a number, and do that same thing for every one of these values of x. And then add these values together and get a number. And then don't forget, we're going to do 1 minus that number. And then we'll come up with a different number and round it to 4 decimal places.